The title of my project is Colors and Light Absorption. Some information that I found throughout my research was that different colors reflect and absorb different amounts of light. When an object absorbs light, it is converted into heat. The higher the amount of light absorbed, the higher amount of heat is absorbed. Lighter colors tend to reflect more light, therefore not absorbing as much heat, unlike darker colors. The purpose of my project was to understand how different colors absorb different amounts of heat from light. I believe this can help in the area of agriculture. Some crops need to be covered in order for them to grow and develop. The crops get affected by the amount of heat they absorb and even the color of light they get. It is important for farmers to know which color would help their crops grow healthy. Apart from agriculture, this is useful for people living in extreme weather in order to protect themselves and their animals with clothes or blankets. My hypothesis is that darker colors absorb more heat from light. The materials I used for my project was a few glass jars, a heating lamp, different colors of cardboard paper such as black, green, orange, pink, and white, a thermometer, some pair of scissors, some tape, 23 liters of water, and a timer. What I did with my project was I grabbed a bucket and I filled it with water so that I would set to room temperature to use the next day. The next day, I filled each jar with 30 ounces of water of room temperature. I wrapped each jar with different colors of construction paper, and I put a thermometer in so that it would measure the original temperature, and I wrote it down in a notebook. I set up the heating lamp so I would hit one side of the jar, and I placed it 8 inches away from the jar. I left the jar in front of the lamp for 20 minutes, and I checked the temperature when the timer ended. I wrote down the final temperature for each jar in my notebook. I repeated the steps for all 5 jars that had been tested. I did 5 trials per color. I later made a table to record all the data and the room temperature per color. I calculated the average temperature per color and included it in all the tables. My variables are that my independent variable is the cardboard paper in 5 different colors. My dependent variable is the temperature of the water filled in each jar after they had been exposed to the light. My control group is the amount of light and distance from the lamp that was kept constant. The time that the jar was exposed to light was the same, and the amount of water and starting temperature was the same. Let's move to my data and results. The data that was initially collected was in Celsius, so I had to convert it into Fahrenheit. The data from the 5 trials was recorded in the top table. The average temperature per color was calculated and included in the table on the last column. The initial temperature for all trials was 75.2 degrees Fahrenheit. The initial temperature was subtracted from the final temperature for each trial to calculate the water temperature increase per color and per trial. The water temperature increase was recorded in the second table, the one at the bottom. It is easier to see the data I collected throughout bar graphs. The one on the left is the temperature increase per trial. As you can see, white is the color that collected less heat from all 5 trials, and black is the one that collected most heat except for the second trial. On the right, it's the average water temperature increase. White and black have a very high difference between the heat that they absorb, black absorbing more heat and white absorbing less heat. The conclusion of my project was that my hypothesis was proven that darker colors do absorb more heat from light. After doing 5 trials per color, I observed that the temperature of water in the jars wrapped with darker and brighter colors was higher than the temperature of jars wrapped with lighter colors. The main difference in the temperature was observed when comparing black and white colors. From the data and results, I obtained that the temperature of the water in the jar wrapped in black cardboard paper was on an average of 6.2 degrees Fahrenheit higher than the temperature of the water in the jar wrapped with white cardboard paper. Additionally, I observed the difference in the temperature in the trials with white, pink, orange, and green that were not very high. I was surprised to find that the temperature in the orange trials was the second highest after the black trials, since the brightness of the colors also impacts the heat absorption. The knowledge gained by doing this experiment is relevant because it proves that colors have different levels of heat absorption that can affect important areas like agriculture when certain crops require higher or lower heat in order to grow. My reflection is that the most challenging part for my experiment was the time needed to do all the trials. Each color had been placed in front of the lamp for 20 minutes, so next time I would use one more lamp in order to be able to test two colors at the same time. I could use less amount of water so that the time could be reduced. To continue experimenting about this topic, it would be interesting to use more colors and also perform the experiment outside to use natural sunlight and to measure heat absorption. Finally, I listed all the websites and resources I used to create the research for my project. Thank you.